Hi everyone, it's been a while since I did a video and I put this question on my Facebook page the other day and I actually thought it was quite a nice one to have a go at. I purposely didn't say anything about what topic it was because that's a huge part of the skill of answering exam questions is working out what maths they want. So we're going to have a little look at this now from that point of view. So you're looking at two right angle triangles. So when you think a question says something about right angle triangles, there's a couple of things you could do, which is bearing in mind is, am I going to need to use perhaps something to do with Pythagoras? Pythagoras crops up all the time and it often can be quite well hidden. So if you've got right angle triangles, start to think about whether Pythagoras might be part of the question. Also, it's asking us for a length. So it's giving us lots of information here. We've got two triangles, one sitting within the other, one inside the other. So you've got a small triangle down here. Just going to draw this on, a small triangle down here inside this larger triangle here. Okay, I'm going to get rid of those lines because I want to write some different marks on, but I want you just to see what's going on there. One triangle is sat inside another. Then put the lengths on. When they give you the lengths, if they're not on, and they often are, but if they're not, write them on because it might help you see what's going on. So AD is 9 centimeters. That's AD there. DE, this one down here, is 2 centimeters, and DB is 6 centimeters. Okay, when you're doing this as an exam question, then just have a look and think, right, okay, what can I work out from that? Oh, hang on, I can see that that whole line across there must be 15 centimeters. And you know what, on an exam, you never know, you might get a mark for that. Not necessarily, but it's worth writing down. Anything you can spot, write it down and don't rub things out. I was marking some papers yesterday and people had written things and rubbed them out and not replaced it with anything else. Don't rub things out. You've got to just leave it in there. It doesn't matter. Right, so we want to work out the length of CB, which is this long line across the bottom. So we're already looking at a right angle triangle and we've got to find a length. So it's looking increasingly more like it might be Pythagoras. I'm going to move on to the next page where I've just drawn something a bit different. And what you can see I've drawn on this page is I've actually taken these two triangles and I've drawn them separately. So here's the smaller triangle, DBE, and here's the larger triangle, ABC. Okay, what we need to do now is we need to see where we're going to go from here. So what do we know? Well, I'm thinking I'm going to need to use Pythagoras to get this long length across the bottom. But to get Pythagoras, I need to work out some side lengths first. This is the side length down here that I'm trying to work out. Here's my CB. This is my CB. And up here, this is the one I actually need to, this is the one I need to work out. CB, beg your pardon. This is the one I need to work out, but I haven't got this yet. I can't use Pythagoras when I've only got one side. The right angle doesn't help me at all. So I need to work out AC. Now that's not too difficult because what I do know is I know that this side length here is 2 in my smaller triangle. What I've got is I've got two similar triangles. That's a mathematical term, similar. It means one is an enlargement of the other. And I know that that's the case because of the angles. This angle here is the same on both triangles. It's the same angle. They share the angle. Both the small and the large triangle share that angle. They've also both got a right angle, not the same place, but they've both got a right angle, which means these two angles here and here must be the same because we know that all the three angles of a triangle have to add up to 180. So if this angle is the same and this angle is the same, then that angle's got to be the same. So one is an enlargement of the other, which means they are similar triangles, which means I can find the scale factor and use the scale factor to work out this side length here. Now, actually, there's lots of different ways to do the scale factor. There's lots of different ways to do this question. But what I can see straight away, just looking at the numbers, is that 2 times, well, I've got that on highlighter, that's a bit unnecessary. 2 times 3 is 6. So I can use that scale factor. We can do it lots of different ways. I can actually use that in reverse. And I can do 15 divided by 3. So I'm thinking that side length must be 5 centimeters there. However, we can do it differently. We don't need to do it that way. I'm going to just get rid of that. I don't want to clog up the page too much. Another way of getting the scale factor is to actually look at these side lengths here, the 6 and the 15, because they're corresponding sides. In fact, they're both the hypotenuse, and we can work out what the scale factor is between those. 15 divided by 6, and that is 2.5. So that's the scale factor. That's the factor of enlargement between the two. That means all the sides in the smaller triangle are multiplied by 2.5 to give us the side lengths of the larger triangle, which means I can use that here. Then I can do 2 times 2.5 is 5. So again, that's come back to 5 centimeters. So it doesn't matter which way you do it. When I know that this side length is 5 centimeters and I know that this side length is 15 centimeters, I can now use Pythagoras because I've got two sides. And we use Pythagoras and we're finding a shorter side. So we're going to take the square of this off the square of that. So I'm going to write it out in full, first of all. 15 squared is 225 and 5 squared is 25. I need to subtract this square from this square because I'm finding a shorter side. 225. 225 subtract 25 is 200. And then to finish it off, I just need to square root 200, which gives me, and we'll give it to one decimal place, 14.1 centimeters. That's the answer. Okay. Equally, you could have written this a bit fancier. It doesn't matter. Some people will write it like this. Square root of 15 squared, take away 5 squared. So some people will write it, it's just a bit quicker. But equally, both are the same. All the working out on there. Really good tip, I guess, with similar shapes is to draw them separately. Helps you see a lot more clearly what's going on. But there we are, 14.1, that's the answer. All working out shown. That's how to do it. I will post some more questions for people to have a go at.